We are going to look at the following chemistry questions. Now, the first question here says, isomerism started when the following happened. Now, we know that isomerism started when vitalism was destroyed. Now, you have your options. Isomerism here detected, no, that's not when it started. When Kekulé discovered benzene structure, no. When Markovnikov discovered the addition of halo acid to unsymmetrical olefins, no. When vitalism was destroyed, yes, that was when isomerism started. We are told that Frederick Wohler reacted silver cyanide with ammonium chloride. Reacted silver cyanide with ammonium chloride, and this gave silver chloride plus what? Ammonium cyanate. Now, all these are inorganic. Of course, we know the theory of vitalism, which states that organic compounds can only be what? Can only be got from organic source and cannot be synthesized in the laboratory. These are all inorganic. Now, when Frederick Wohler left this under the sun, there's temperature difference. So we have NH4OCN. It changes under heat. This is heat, so we can put heat here to give NH2 C double bond O NH2. We call this urea. So isomerism started when urea was discovered, and the theory of vitalism, which states that organic compound can only be synthesized or can only be gotten from organic sources and cannot be synthesized in the laboratory, was what? Destroyed when Frederick Wohler synthesized an organic compound, urea, from what? Inorganic. Now, if you look at urea and ammonium cyanate, which is inorganic, you discover some similarities. Urea and ammonium cyanide, you discover cyanate, you discover some similarities. What are the similarities? Now, you see that they are isomers. They are compounds of the same molecular formula but different structural arrangement. That is what isomers are. Isomers are compounds of the same molecular formula but different structural formula. Hence, if you look at these two compounds very well, how many nitrogens are here? 2 nitrogen, 1 and 2. How many are here? 2 nitrogen. How many hydrogens? 4 hydrogen. Many hydrogen? 4 hydrogen. How many carbon? 1 carbon, 1 carbon. Oxygen, 1 1. So it's that they have the same molecular makeup but different arrangement of the atom to give what? Different compounds entirely. So this experiment was what? Conducted by Frederick Wohler to disprove the what? The law of vitalism, which states that organic compounds can only be gotten from an organic source. So the correct answer to this question is option D. Is the correct answer to this question. Let's take a look at number 2. Which class of alcohol does 3,3-dimethylhexane-2-ol represent? First of all, let's write out the structure. 3,3-dimethyl. So we have CH3 hexane 2-ol. It means the OH group is here. Then we have what? This is H, and then continues CH2. How many carbons have we written? 1 2 3 4. Then CH2 and what? CH3. 1 2 3 4 5 6. This is hexane 2-ol. Our numbering, of course, started from this direction. This is 1. Here is what? 2. Here is 3. Here is 4. Here is 5, and here is what? 6. Now, when we say 3 3, it means that at carbon number 3 there's a substituent. There are substituents, so we have to remove this hydrogen from here and then put the substituent there. So you have something like this: C, one substituent upward. If I should use this to represent the substituent, so we have CH3 here and what? Another CH3. So this is the structure of 3,3-dimethylhexane-2-ol. What class of alcohol is it? Is it primary alcohol, secondary alcohol, or tertiary? Now we need to know the kinds of alcohol. We said we have 3 classes of alcohol. Primary alcohol, when the group carrying the OH is attached to just one alkyl group or one carbon, we say it's a primary alcohol. Then when the carbon carrying the OH is attached to 2 alkyl group, we say it is what? Secondary. Why, if it is attached to 3 alkyl group, we say it is what? Tertiary. Now, alkyl group can be anything. Alkyl group can be CH2, CH3. Can be anything, can be CH3, CH3. So in the situation where you have this carbon carrying the OH, which is this one, this is a carbon carrying the OH, right? In the situation where you have this carbon attached to 2 other groups, 2 other carbon directly, then you say that kind of alcohol is what? Secondary. Are we getting it? Because we say secondary, it has 2 what? Alkyl group. Now, in most cases, you just say whenever the carbon carrying the OH is directly attached to 2 other carbons directly, then we said it's what? Is a primary alcohol. Not paying attention to anything that follows, just the other what? Carbon. I mean secondary alcohol. So this is secondary what? Alcohol. So the correct answer here is secondary alcohol. Now, how about if you have something like this? CH3, CH2, then CH2, OH. What class of alcohol is this? This is what? Primary alcohol. Why? Because this carbon carrying the OH group is attached to just one word? Carbon. How about if you have OH? Then you have CH3. What? CH3 and CH3. What class of alcohol is this? This is what? Tertiary, because the carbon carrying the OH is attached to how many other carbons? 1, 2, and what? 3 other carbons. So the correct answer to this question is option B, which is secondary alcohol. Now, 1-chloro-2-hydroxybenzene is an example of which of the following? 1-chloro-2-hydroxybenzene. This is the benzene structure. We have OH. Let's say this is the structure. It may not be really correctly drawn. Now, this structure, what kind of alcohol is this? This is a phenol. This is an example of a phenol. Because why? It has the word OH group attached to a benzene. Whenever something has the OH group attached to a benzene, we call it what? A phenol. So this is an example of a phenol. The structure of phenol is this. This is structure of phenol. So any class of alcohol that has this OH group like this attached is what? A phenol. Are we getting it? So that's the answer to this question. This is the structure of phenol. Now, the difference in alcohol and phenol is, now, what is the difference between alcohol and phenol? If you see all the alcohols that we've been writing since, you have CH3, CH2, and what? OH, isn't it? And the rest. Now you have CH3, COH, then H and what? CH3. Then let's say you have CH3, COH, CH3, and what? CH3. These are the different classes of alcohol, ranging from 1 degree or primary. You either call it primary alcohol 1 degree, this 2 degree, or what? Secondary. Then you have the tertiary alcohol. These are tertiary alcohol. Now, what is the difference between them? This is the structure of what? Phenol. This is the structure of phenol. Now, what is the difference between this phenol and this other alcohol? Now, you discover that in other classes of alcohol, all the groups attached are what? Saturated. They are saturated in the sense that they have all single bond. You see this one have single bond, single bond, single bond. There is no double bond. Are you getting it? They are all what? Single bond. But in phenol, this carbon here, of course we know that each of these branches are carbon. For instance, this is a carbon double bonded to what? To another carbon, to what? Carbon double bonded to another carbon, to carbon, like that. Are we getting it? Then this is a carbon double bonded to another carbon, like this. This is the structure. Okay, 1, 2, 3, 4, 5, 6. Now you discover that in this structure, the OH, or the carbon carrying the OH, is attached to a carbon bearing a double bond. And whenever a compound is bearing, or a carbon is bearing a double bond, we say that that compound is unsaturated. Whenever a carbon is bearing a double bond, it's said to be what? Unsaturated. So in phenol, the OH group is attached to an unsaturated carbon. That is the correct answer. Substituent are not attached. That is not the answer. The OH group is attached to a saturated. No. In phenol, the OH group is attached to unsaturated carbon. So that is the differences. Now, one of my project students has successfully nitrated ibuprofen using concentrated nitric acid and concentrated sulfuric acid rather, but she's in a dilemma as to how to confirm if the reaction was really successful. As a chemist, what would you advise her to do? Now, this is the structure of ibuprofen. Now, when ibuprofen is nitrated, what will happen? This group that you are seeing here, this is a little bit more advanced than your level, H2SO4 and HNO3. If this is nitrated, what will happen? It will form what? NO2 plus with other group attached. Now this NO2 plus will attach to the ring. Are we getting to the benzene ring? Now this is to say there are different principles that actually governs the attachment of this to this, depending on the kind of groups that are attached, like the substituent, if they are metal direct or para direct or that. But we do that in subsequent chapters. Now, but the most important thing is that you have what? NO2. Now, the best way to actually do this, if I were to advise the student, is to perform a sodium fusion test or a sodium amalgam test. Now, the sodium fusion test will actually tells us the presence of what? Nitrogen in this particular compound. It tells us the presence of nitrogen in the compound. Are we getting it now? So, if nitrogen is there, that is to say that something was actually nitrated very well. But if nitrogen is not there, it means that it's not what? Nitrated very well. Now the next one is the following experimental technique will be required to collect a solid material that is insoluble in a complex mixture. Now, if a material is soluble rather in a complex mixture, the best way to go about it, if it is soluble, first of all, so you need to check for the purity using what? TLC check. TLC means thin layer chromatography. Thin layer chromatography. You have to carry out thin layer chromatography first of all to check for the what? For the purity. Then you will now carry out column chromatography. Column what? Chromatography to separate the individual mixtures. Column chromatography to separate the individual mixtures, and then carry out what? Recrystallization, so that you can obtain the solid. Recrystallization will help you to actually what? Obtain the solid. So the correct answer to this question is option B. Now you have the question here. The question says, which of the following compound will react with sodium hydroxide and 2-chloropropane form, or which of the following compound with the reaction between sodium hydroxide and 2-chloropentane? Now 2-chloropentane is CH3, then we have C, Cl, this H here, CH2, CH2, 1 2 3 4, and then CH3. These 2-chloropentane react with sodium hydroxide. Now the reaction will be elimination reaction because of the presence of the base here. This is a base. Sodium hydroxide is a very strong base. Are we getting it now? So when sodium hydroxide reacts with haloalkanes or alkyl halide, when sodium hydroxide reacts with alkyl halides or haloalkane, what will be formed? It will form, or the process will undergo what? Elimination reaction. Now in elimination reaction, the products that will be formed are, it will form two products. One is a major product and the other is a minor product. Now first of all, elimination reaction is called alpha beta elimination. Elimination reaction is called what? Alpha beta elimination. Now in alpha beta elimination, you need to spot out the alpha carbon and the beta carbon. The carbon carrying the chloride group or the halogen is usually the alpha carbon, while the carbon closest at both sides is the what? Beta carbon. So we have one beta carbon to this side and another beta carbon to this side. So what we do in elimination reaction is that we eliminate hydrogen from one of the beta carbon and eliminate the chlorine from the other what? From the alpha carbon. So in this case, we are going to form two products, but which will be the major product? Now, the least substituted is usually the major product. That is to say, the one with the least number of hydrogen. Elimination from the one with the least number of hydrogen is usually the major product. Let me take that again. In elimination reaction, you follow the alpha beta elimination procedure in such a way that you eliminate the chloride group on the alpha carbon and hydrogen from any of the beta carbon. Now, in this case, you have two beta carbons. The beta carbons are the carbons that are closest to the alpha carbon at either side. So at the left hand side you have CH3, and at the right hand side you have what? CH2. Now you can form two products according to the Zesef and the Hoffman's rule. The two products that will be formed, one will be more stable than the other. Now between these two and this one, which one will form the major product? I said the major product is formed from the one in which the hydrogen is removed from the beta carbon with the fewest number of hydrogen, while the minor product will be formed from the one whereby the hydrogen is removed from the beta carbon with the highest number of hydrogen. So if we remove hydrogen from here, now whenever you are removing two sigma bonds, that is to say whenever you are removing a hydrogen and a chlorine group, a double bond will be what? Formed in between. So what will be the product of this reaction? This will give us CH. If we remove one hydrogen from here, here becomes what? 2, isn't it? We remove one hydrogen from here, one is now down CH2, then double bond, then you have what? CH. Why? Because you remove what? The chlorine. So when you remove hydrogen and chlorine, a double bond is formed. So we have what? The chlorine on top here. Then you now have CH2, CH2, and what? CH3. Now this is one product that will be formed. Now the other product that will be formed is the one in which the hydrogen is removed from this beta carbon. Which one did we do? The one that the hydrogen was removed from this beta carbon. Are we getting it now? The second case is the one that it was removed from this beta carbon. So this becomes CH what? 3, then CH. Now if you remove the chlorine from here, you say chlorine is gone from here. Are you getting it now? So what will be formed here? Double bond. Now CH. If you remove one hydrogen from here, what will be formed? To be left with one hydrogen here. Instead of CH2, you'll be having what? CH. Exactly. So continues like that, and this gives us CH2, CH3. Now I told you that the major product is the one in which the hydrogen is removed from the carbon with the fewest number of hydrogen. So between this carbon and this carbon, which one is having the fewest number of hydrogen? You agree with me that this is having the fewest number of hydrogen. So the elimination product that corresponds to the removal of hydrogen from this one is the major product. And which of them correspond to this is the one under? I will remove hydrogen from here. So this is the major product of this reaction. Major product. And this is the minor product. Now what are the names of these products that are formed? Of course, you know this H plus this Cl will react to form what? HCl as byproduct. Same thing applicable here. They will react to form what? HCl as byproduct. So if I remove this from here, so there's no longer this here again. So it form HCl as byproduct. Are we getting it? Byproduct of the reaction. Now, if we follow this, the name, what will be the name of this compound? Now it's proper you write the name under, but because of space, I'm going to write the name what? On top. What will be the name of this compound? This compound is what? Pent 1 in, and then what is the name of this compound? This is 1, 2. This is pent 2 in. So the elimination, we form pent 1 in and what? Pent 2 in. So the correct answer is pent 1 in and pent 2 in, which is 3 and 4 only. That is the correct answer to this question. 3 and 4 only. Now, let's look at the next question. Which of the following best describe the transformation of 2,2-dibromobutane forming butane? 2,2 or 2,3-dibromobutane. butane, 2,2-dibromobutane to form what? Butene. Now this is an elimination reaction also, but the name of the elimination reaction is dehalogenation of what? Vicinal dihalide. Dehalogenation of vicinal dihalide. Now what is 2,2,3-dibromobutane? This is CH3, this bromine group BRO, then you have what? H, C, BRO, H, and then CH3. Now whenever you have two bromo group like this in such a way that they are adjacent to each other, you call the compound vicinal dihalide. What do you call it? If you call it vicinal halide. So this is a vicinal dihalide. Whenever you have two halogen group, in this case bromine bromine, if it is chlorine chlorine, adjacent each other in a compound like a single bond like this, you call it a vicinal what? Dihalide. Now the correct option here is not dehydration of alcohol. Now look at what happened. For it to form but2-ene, it means these two bromine group have to leave, because I told you that when two sigma bond leave, one pi bond is formed. Are you getting it now? So whenever two sigma bond leaves, a pi bond is formed here, and the pi bond is a double bond, like at least. So when these two, an example of elimination reaction like the one we did the previous time, just that here was now what? Hydrogen. So here will be what? CH3, then we'll have C, double bond, C, this is H, and this is what? H, oh sorry, this H here, then here is CH3. What is this structure? This is but what? 2-ene. Why? Because you have this, if you number this is number 1, this is number 2, this is number 3, and this is what? Number 4. At number 2 you have a double bond. Now you see that what happened? The halogens group here what? We are both removed. The two halogen group here removed. So in this situation you call it dehalo. Are you getting it now? It is what? Dehalogenation. Removal of what? Halogen. Like deactivate means what? To remove the activation. Dehalogenation of vicinal dihalide. We know what the vicinal dihalide is, right? So the correct option to this question is dehalogenation of vicinal dihalide. Now the next question says a series of compounds in which each member differ from the members before or after it by structure. Of course we know that this answer is what? Homologous series. For instance, you have CH3, or let's say not CH3, you have CH4, then you have CH. After it, by the structure is supposed to be something like CH2. By this structure of CH2 is this CH2 A6, this CH3 H what? 8, CH4 8 what? 10. You see that every member differ from this one by what? A CH2 group. Of course this is something that we should be memorizing by now, that the homologous series is a family of compounds in which every member differ from the successive member by a CH2 group. Now we have an organic compound, a calculation question. An organic compound is found to have 20% carbon, 22% hydrogen, 2.2% hydrogen, and 77.8% chlorine. Which of the following determine the simplest formula of the compound? Now the simplest formula of any compound is the what? Empirical formula. The simplest formula of a compound is the what? Empirical formula of that compound. Are we getting it now? So to get the empirical formula, first of all we write the component atoms out. We have carbon, hydrogen, and what? Chlorine. Is that so? Now let's write out the percentages. You have 20% carbon, 2.2% hydrogen, and 77.8% chlorine. Now the next thing we do to find the empirical formula is divide by the atomic mass rather, of each of these elements. The atomic mass of carbon is how many? Is 12. So we divide by 12. The atomic mass of hydrogen is how many? 1. And the atomic mass of chlorine is 35.5. Now if you press your calculator to get this, you have 20 divided by 12, which is equal to 1.66. So this gives us 1.666. Now 2.2 divided by 1 will give us 2.2. 77.8 divided by 35.5 divided by 35.5 will give us 2.19. So this will give us 2.19. Now what we do next is divide by the smallest here. The smallest here is 1.66. So we have 1.66 divided by 1.66 divided by 1.666. And when we divide it, 1.66 divided by 1.66, of course this will give us 1. 2.2 divided by 1.666, that will give us 1.32. So here is 1.32. The next one is 2.19 divided by 1.666, that will give us 1.31, which is approximately 1.32 also. Now what we are going to do is we are going to look for something that will multiply this until it gives us a whole number. Now if we take this out, you have carbon, hydrogen, and what? Chlorine. This is 1, this is 1.32, and this is also 1.32. Now what do? We look for a value that when we multiply it round is going to make this one to be whole number. If we try 2, this become 2, this become 2.64. 2.64 is not close to a whole number. Are we getting it? So we can't use that. Let's multiply through by 3. So multiply through by 3. This becomes what? 3 times 1 is 3. 3 times this is, I think this is 3.96, and 3 times this is also 3.96. So this is approximately 4, and approximately 3. So we are going with what? 3. So the formula of the compound is C3, because under this you have what? 3. Then what do you have? C3 H4 Cl4. So the correct answer is C3 H4 Cl4. So the correct answer is supposed to be this C3 H4 Cl4. So let's correct this, and this makes this the correct answer to that question. Not Cl3 but Cl4. So that is the correct answer to that question. Let's take the next question. That is all.